so much of the course is about groundwork understanding and fundamental knowledge. And sometimes in engineering we get really impatient for the application because we like to do things. Like we want to take apart the dryer before we know what really how a dryer works, or it's that instinct to experiment. Well, finally we get to play around a little bit. And WMS is a tool that is pretty unique in that it's both easy to use, but it's also very powerful. And so a lot of powerful tools sometimes are intimidating and take weeks and months to learn how to do anything. But this one, I think, has, largely because it's written by students in a lot of ways. The programmers that do the day-to-day revisions on WMS are oftentimes university students themselves that they use. And so I think it's partly they focus a lot on their users, who includes the Federal Highways Administration. This WMS program gets a lot of support from the federal government, but there are for-profit consulting firms that use it as well. So we're going to dig into that today. Just by way of announcement, homework 10, which I'm going to be giving you today in class, that is due next week. Submit on MU Online. One other announcement that I haven't put on here is that the course schedule that I gave you at the beginning of the semester, that's shifted. I mean, if you look at what the subject for today's lecture is, according to that course schedule, it said that today we were going to do like field measurement or of time concentration. Well, we covered that in class before spring break. And so what that does is it allows us to have 3 WMS lectures instead of only 2. And so the flooding and risk part is still going to be 1 lecture, and the groundwater is still going to be 1 lecture, but instead of 2 WMS lectures, we'll have 3. Any questions about that? All right. Well, this program that I've already mentioned a little bit, it itself doesn't have hydrologic models that have been developed by the company Aquaveo, but rather it uses standardized models that were developed in most cases by the federal government that have been validated and are accepted by lots and lots of history, and in the literature there are a lot of references to those models like National Flood Frequency, sometimes also called National Stream Flow Statistics, HEC1, HEC-HMS, TR55, TR20. If you've been doing hydrology, probably those terms are already familiar to you. What this does is it sits on top of programs that otherwise are kind of clunky, or otherwise you have to do a lot of work to get ready, and it makes the process of preparing a watershed model a lot simpler. Because a lot of these watershed models were developed in the 1970s, and maybe you weren't around in the 1970s like I was, but I mean I wasn't programming then, but I started playing around with computers pretty early, and it was a nightmare. In the days before you had a mouse, and when your screen was just green and black, software wasn't as easy to use then as it is now. And so these models that were developed in the 70s would require the users who were trying to predict runoff with them to manually type in so many parameters. And even though it was a computerized model, sometimes you have to have a paper map, and you'd be tracing your watershed boundary with a paper map, let's say with a topographic map, rather than it being from beginning to end just an all-digital experience. So what WMS has done is it's taken these old models and it has built an environment where it's easy to use them, and it's easy to prepare the data for them, and it's easy to see and understand the results and export those results for display in like spreadsheets or in reports. And so when I say a preprocessor, what I mean is that it'll go and get the data, and it will do the calculations needed for the hydrologic model to have all of the inputs satisfied. You know, a computer program takes a series of inputs and then it gives you an output. And the output of the hydrologic model is going to be a runoff hydrograph in most cases. And so it will pre- and post-process these clunky old-style hydrologic models. So it's a graphical user interface for these models that you used to just have to key in the text manually. It will go online, and so it'll bypass the servers that we took a look at in class last time. You know, the national map, where you could, if you wanted, go get a DEM data and download that data set, and you could go and get your soil type data directly from the USDA. Well, you'll just, in WMS, tell it the area that you're interested in, and it'll go get that information for you, so that you don't have to, you know, track down websites and send in requests for an email once the server decides to give you your data. So that's really kind of a newer development. It's just in the last about 5 years that WMS not only could read the digital data, but it would go get it for you. And I think it's probably the most valuable thing that they've ever done. It has built-in calculators to read watershed characteristics and then calculate some of the inputs that are needed. And then it has a series of standardized reports that it can generate so that you can look at the hydrographs. And a lot of time, just as in design, analysis is iterative. You know, sometimes you'll do an analysis and you think you've got everything right, and you hit the go button and it'll execute the model, and then your runoff hydrograph is just ridiculously big, and you realize, I've made a mistake somewhere. You know, and so you maybe need to reconsider some of the curve number values. And so being able to see the result of your model inside of the modeling environment is really useful, and so that you don't have to take so long to optimize the modeling process. Now, over the years, WMS, in increasing functionality, has expanded to integrate with a lot of commonly used tools. HEC-RAS is a tool for water surface profile modeling. And if you want to know what the water depth is in a stream, then HEC-RAS is a program that can be used to calculate that. And so they've integrated what's a hydrologic program, you know, which is mostly about taking the stream characteristics and the rainfall characteristics and the watershed characteristics and just giving you the Q. So how is that Q, the flow rate, going to be used? It's going to be used by a hydraulics program or by a culvert program, HY8, which you've already used. And there's also integration with a program that's called C=W2, and that's developed by, I think it's the Bureau of Land Management. And C=W2 is all about the mixing of water inside of lakes. And so WMS can be used to prepare models for that as well. Let's take a brief tour of some of the key features that are in the window. And one thing I'll point out is that some of the slides here are from version 9 of the software, whereas you've downloaded version, I think, version 10. And that's all right. Not much as far as like the macros are the same and these buttons are the same. So here's the main program window. And your menu bar is across the top. These macros have like predefined, they'll bring up dialog boxes that will execute a series of commands. For example, if you wanted to zoom out to the full extent of the model that you are working with, that's what this button is for. If you want to bring up display properties, that's what this button's for. So those are the macros. The graphics window is the largest because that's where you're getting most of the information. You can think of it as where you're doing the work. You know, over here on the left, the Project Explorer is mainly managing layers, and it's in some ways a file browser. And so you're turning on and off layers. And then when you select objects in the graphics window, the properties of those objects will come up here in the Properties menu. So the Project Explorer we've talked about. These static tools on the left, these ones, are going to be present regardless of which module you're in. And here across the top they're different modules, and depending on which module you're in, sometimes the menus change, and some of these non-static tools will change as well. That's why they're called the dynamic tools, is because depending on the module you're in, the dynamic tools may be different. And sometimes that can be a little bit confusing, like you'll be looking for a certain tool and then you'll realize that you're in the map module instead of the watershed module, and we'll talk about what all these different modules do. The nice thing is that they've come up with a couple of wizards that automate steps that used to be successive, and so you kind of had to either write down a workflow or memorize it, do this, then do that. But these wizards that they've developed kind of took those series of tasks that used to be repetitive and put it all into an order, so it walks you through the workflow and you don't have to remember exactly what to do first. These are drawing tools, and so that you can, if you're generating a map, you can put text on the map or draw lines, standard drawing tools for rectangles and curves and so on, that are completely separate from any feature objects that you may want to draw inside of the graphics window. And feature objects are actually related to the data itself, whereas these drawing tools, it wouldn't be interacting with the data at all. It's just something for visual presentation purposes, if you wanted to write a note to yourself or if you just wanted a line to be able to see it. Down here in the help strip, you can sometimes get messages. When you hover over a certain tool, it will tell you the name of that tool in the help strip, and sometimes a little brief message about how to use a tool. And so it's pretty useful. The cursor coordinates, wherever you're moving your cursor over the graphics window, it's going to be giving you coordinates. And depending on what projection you're in, that coordinate system may be anything from latitude, longitude, or there are other projection systems that make use of state plane coordinates that are specific to each state. It's kind of like a grid system with X and Y. And so we'll talk a little bit about projections. Has anybody here taken a GIS course before where you learned the difference between like UTM and Zone 17, like hardcore GIS stuff? Okay. You do? All right. Well, that's something where you can accidentally fall into the deep end of the pool really easily and screw things up, and your data will be on one part of the screen and your map images will be on the other part of the screen, and it's because they're not projected in the same XY coordinate system. And exactly, yeah. You'll bring in a shape file, and the shape file will be in the wrong spot. Your project is in Virginia, but then you open up the shape file and it shows it in Brazil. So that's the sort of thing that's happened to me before. The good news is that these wizards usually will guide you to the correct projection, guide you to the correct zone and the correct units, and so the sort of thing that you really had to in the past be kind of meticulous about, I think, unless you end up going down the wrong turn, will never be an issue for you, I hope. And I hope on my sake too, because since these wizards have become so polished, I kind of my skills of solving problems when things do get in the wrong spot are much diminished compared to how they used to be. I used to be able to move things around, but that's become quite a rusty skill. Whenever you are selecting an object, it'll give you some information about that. And by an object, you can select just the points or the entire polygon or an arc. Talked about the properties window. Here is a description of your unit system. That's related to the discussion we had about projections already. And then if you are in one of the modules that makes use of a model, and by model it would be like TR20, TR55, this will remind you of what model you're preparing things for, because you can be working in an area and gathering data from that area to put it into any one of many different models. But you can switch between those models with this drop-down box. Any questions so far? Okay, I've already mentioned the modules and how when you switch from module to module, it'll adjust these dynamic tools. And most of the time we'll either be in the map module or in the watershed module. And so this is the map module. It looks like compass rose, and then the one next to it is the watershed module. At the very end, when we're ready to do our modeling, then we'll move into one other module, but we'll talk about that in class next time. Today I think we'll only be in the watershed and the map modules. And these wizards are fantastic. I'm not sure what some of these icons are, though. Like I think maybe these are supposed to be wizard hat, like a wizard hat on roller skates or something. I don't know what the icons are, but I sure like what they do. You will too. All right, so I already mentioned that what we're going to be using is mostly the drainage module and the map module. But then once we finish our work there, we can go into the hydrologic modeling module, and that's where you actually can interact with the underlying theory of TR20 or HEC1 or HEC-HMS. The GIS and terrain data modules are mostly about getting data from online sources and getting the information that you need to find out things like the basin elevation, the average watershed slope, and the 2D grid is kind of more an advanced feature that we won't be getting into. But the river module is where you would export the output of the hydrologic module, and then you'd start preparing something for like HEC-RAS. What we'll be focusing on, though, is just the hydrology part of WMS. We won't get into any hydraulics. Okay, we won't focus a lot on looking at these tools or macros. We'll just kind of learn them on the fly. But I do want to point out that when you have a watershed open, then you click on any kind of a feature object, whether it's an outlet or it's the watershed itself, then it'll bring a lot of information about what you have selected over here on the right side. So you can see that right now when it's selecting a feature point, that's a watershed outlet. And right now, this is in the module that's interacting with a watershed model. And so you can see that right now we're trying to prepare everything that HEC1 needs to be able to estimate the runoff over time. And so we have an outlet picked, and it tells us that's 30 square mile watershed. And one of the important tools that you'll need to occasionally do is just like the zooming and panning. And you can use the scroll button on your mouse for zooming and panning in a lot of cases. But if you get totally off site and you just want to bring everything back into perspective, then the frame image is a way to do that. What we're going to begin with today is opening up background images. And the nice thing is nowadays is it'll go and get the images from online. And the bad part about that is that they download slowly because they're coming from public servers. And so when I'm downloading a background image, you know, what you may be downloading is generally an uncompressed file format like a TIFF. And TIFFs are big, so like what you were looking at on screen may be 1 or 2 or even 5 megabytes. And some of these servers will only feed data at about 10 to 20 kilobytes per second. And so it can be a little bit painstaking to download those TIFFs. And so there's an option for you to cache it and save it locally once you do download it, so that it's just a one-time process and you're not constantly re-downloading the same image every time you start WMS or every time you pan or zoom in and zoom out. So they've tried to overcome some of the problems that come up when you have the online data. In fact, some of the servers are so slow that what they'll do is the Aquaveo people have downloaded all of the data from a government website, and then they keep it on an Aquaveo server so that you can get it from them. And, you know, because it's data sets that'll only be updated once every 5 years kind of a thing. So they're always looking for a way to speed up. All right, so here's what we're going to do. I'd like you to start the program. Does everybody have it installed? Did you get it? Can you download it now? And it won't? Do you have it? Okay. Good. All right. Well, I'm sorry you're not going to have the full experience today. Maybe you can scoot over and look at what he's doing, or I guess you can look at what I'm doing. Start the program, and if you haven't already, I think it'll prompt you to enter the registration details, and so you can just, when it gives you that pop-up box, click on the registration details. So here in the About section, it tells you that what we should all be running, I think, is version 10.1.12, which was released on March 1st. That's what everybody's got. All right. All right, so I'm going to show you how to, first of all, locate a project area, load images, and then draw some things on top of an image. And so one of the easy ways to do it is to click on this button for Get Online Maps. And so it has a plus, it's a couple of colored polygons and a plus. So if you click on that, then it's going to bring up a little tool that allows you to locate a project area. And if you know the latitude and longitude, like the coordinates, then you can type those in here. So anybody know the latitude and longitude of Blue Sulphur Road in Ona, West Virginia? Off the top of your head? I don't. Because I don't need to, because they have provided the locator tool. Now, if I wanted to, I could just zoom in, and I think probably everybody here, we're all map people, right? We could zoom in. You could zoom in on your house just this way. Right? We know we're in the tri-state, so here we'll zoom in here and progressively zoom. Oh, now I'm lost. No, here I am, Huntington. Getting closer, progressively zooming in. But, I mean, that potentially could be tedious. And so if you turn on the locator tool, you could just say, what. You could put an address, and then the where would be the city and state. So I'm just going to say Ona, West Virginia, and have it find Ona, West Virginia for me. And there it did. It was so easy. And here's Blue Sulphur Road. Now what I'm not sure about, what I haven't tried, is whether it will go to an exact address, like 5,000 Blue Sulphur Road. 5,000 may not even be a street address for all I know. What about Blue Sulphur Road? No. Well, I'm still pretty happy just to have it find cities for me. So here's Blue Sulphur Road, and so I can say this is my project area. Now, identifying your project area in hydrology can be a little bit tricky because you know where your culvert is going to go, right? Let's say someone says, we've got a road, here's this Blue Sulphur Road, we're putting in a culvert right here. And so you could zoom in super close and say, wow, I found this is the little side street. My culvert is going right north of that little side street. So anyone think of what would be a potential problem of zooming in so close when you're going to start your watershed modeling? You can't see the whole watershed. Yeah, what you're essentially doing right here is you're defining the boundaries of what you're interested in. And so it's going to use whatever boundaries. When you click OK, it's going to say, it's going to start thinking of the extents. And all we're doing right now is we're just telling it where to go get the imagery. But you can use that same tool for getting the elevation data. So if you're really zoomed in, your watershed boundary may go beyond the range that it's going to go download your data for you. And so you need to be careful, and it's fine when we're just getting the image, but we want to be more cautious when downloading the DEM. So I'm going to cancel because I zoomed in too much. I'm going to go back again to the Get Online Maps, zoom out. Thankfully it remembers. Zoom out a bit more. All right, so I'm going to go get the maps for here. And it gives you an option, and the three that I generally use are the first three that show up. One is DOQ, a digital ortho quadrangle. It basically means an aerial photo. One is a street map, and then a topo map, which focuses more on things like elevation contours and physical features rather than man-made features. And so let's start by getting the world imagery. And now it's going to take a while to download. Even though we've said where we want the data from, you can see here it says it's processing. And this is why it's important to sometimes cache the data in the memory, is because it'll do this whole processing thing anytime you pan, anytime you zoom out or zoom in. I didn't want to see the error log anyway. All right, so let's see. Okay. The area I'm interested in, you see this open area. It's grassy and there's no trees. So I'm going to zoom in there using this zoom tool. And you can draw the extents of where you're interested in, and it'll zoom in so that that is included in the screen. Now right now it's processing again. This looks pixelated because I zoomed in, but how many times is it going to say that? Now it's less pixelated. All right, so to avoid having to go through that process again, I'm going to right-click on World Imagery and Export. And it asks you, really the only thing that you need to worry about here, for resampling ratio, what that means is how much more data do you want it to download compared to what you actually see right now. Now, this window is probably like 900 pixels by 500 pixels. Everybody knows what a pixel is, right? It's like a dot. And so by saying 2 here, you're telling it, get twice as many dots as we can actually see right now. And the advantage of having that is that if you zoom in, it'll still be clear. So why not say 100? Well, because then it's downloading in such a high detail that the file's going to be big and it's going to take a long time to get. So it's kind of like a juggling act. You want the resampling ratio to be high enough so that when you zoom in, the features you're interested in are still clear. But you don't want it to be so high that you've wasted time and bandwidth getting an unnecessary image file. So I'm just going to leave it on the default, when in doubt. So just click OK, and it'll ask me where to put it. So I'm going to create here a temporary folder on the hard drive. And I'm not going to bother naming it anything unique. I'm just going to tell it the location, and it will download that file. Now, why can't it just save what it's already showing? Because remember, it has to go get twice as many pixels than it's already showing. So this is going a little bit faster than sometimes they do, but I mean, better than dial-up, not quite maxing out even the DSL speeds here. Any questions so far? I hope you guys are as excited as I am. WMS is awesome. You don't even know how awesome it is yet. It's okay. Now, image pyramids, if you had an old computer, right now would be an important decision. Oh, should I do it or not? Nowadays, it doesn't really matter. Image pyramids are, they're just like cached views of what it looks like when you're zooming in a certain level. So yes or no, it doesn't really matter at all because it just executed those images. So now you can see here's World Imagery TIFF and then World Imagery. So World Imagery was the website version that's streaming to you. TIFF is downloaded on your hard drive. So if I turn off the World Imagery, now why does it look different? It's because this is, when you zoom in, it may be using a different source file. So I can zoom in and it's still clear. So to get that higher resolution, they may have had to go to like a different date that area was flown. Okay. So if I zoom out though, it's not going to get more data from the server. It only has the extents that were on the map when I first exported that file. That's fine. All right, so let's do this. Let's also add data, get online maps, and get the street map and the topo map. So I'll do the street map. I don't know if you can do more than one at a time. I've never tried that. So I'm going to do Control, Yes, it looks like maybe you can do 2 at a time by holding down the control button. Hopefully the whole thing doesn't burst into flames now. No, it's getting them both, topo and street. Whatever that means. I'm going to turn off the world imagery so that it's not on top of anything else. I'm a little surprised it's not saying processing. Let me turn off the street and see about that topo. How come we're not seeing it? Okay, well, I'm going to delete it. Maybe I should do it one at a time, because if I turn this on, huh? Did you do both? And you were seeing them? Are you getting that same error message every single time that I'm getting? That must be a Marshall computer special. That's, all right, let me go get it. I'm going to add it again. Get online maps. I'll get the street map. Processing, okay. Hopefully I'll be able to see this one. You know, these street maps are remarkably good, the ones that it gets. And, yeah, I think it is. Yeah. What I really like about these street maps is it has more than just the streets. Oftentimes, it's easier to see like watershed boundaries and ridge lines on these street maps than you can actually even see on the topo. Like right here. I mean, it's really nice and clear where that watershed is, right? Like they do a great job, I think, of showing the texture of the land surface. And so I'm going to take the street map and create my exported local version of it. All right. Now it's saving it as a TIFF, but it's saving it as a GeoTIFF. And a GeoTIFF is a special kind of a TIFF. TIFF stands for Tagged Image File Format. It's uncompressed. In contrast to a JPEG, which uses lossy compression, and you can sometimes see little artifacts. A TIFF only has lossless compression, and so you'll never see compression artifacts. But a GeoTIFF has a world referencing file. And so built into this file is coordinates of where it belongs on a map, so that I could open this same image file in another program and it would appear in the correct place. So that's what a GeoTIFF is. Now this one is going really slow, 3 kilobytes per second. They're killing me. Microsoft, of course, right? I don't know where it's actually hosted. At least it's telling me the estimated finish date, so I can go get a cup of coffee and know when to be back. 1654. Oh, there it is. All right, image pyramids, don't care. All right, so now I can turn off the street map thing, and I'm going to go ahead and get the... oh, I clicked on the wrong one. Okay, topo. So we can see what a topographic map is. Back in the olden days, a professor would actually bring in a paper topo map, but I'm guessing many of you, probably nobody here, has ever seen a paper topo map before. I don't know, I guess they probably still print them. So on the topo map, you can see that it has the contours shown. And if you zoom in, sometimes you can see things on a topo map like where old wells are. And it'll indicate springs. I mean, the kind of place where a topographic map is most useful for is in undeveloped areas. So if you're going camping out in Cranberry Wilderness, for example, it would be really great to take a printed topo map with you, because things you need to know about, like where springs are, where are lakes and streams and so on. All right, so I'm going to do the same thing of exporting that. Oh, I already did the street map. I'm going to export the topo map. And then once it's exported and we have the local copies, we can delete these cached streamed versions. They're probably wondering why they're getting so many requests for the same area in West Virginia. Probably they're not wondering. There's probably no person who's actually involved. So there, we've got our imagery. And so what I'm going to do now is I'm going to right-click on the topo map and delete it. The advantage of doing that is that when I pan from place to place, it's not going to care. So like, see how it says processing? I want to get rid of that, delete it. Okay, so we have these and can turn them on at will as we want them. All right. So what we're going to be taking a look at is a watershed that is running through this backyard here. So I think it's probably best seen on the street map thing. Oh. At this resolution, it's not showing those nice ridge lines that I had earlier. I know where it is. All right, so any questions about what we've done so far? All right, we're at 4:57. Let's take that traditional 5-minute break, and when we get back together, we're going to start talking about elevation data. And I have a little activity for you to run, so we'll do a 5-minute break, and then actually, just in case you get back early and you want to practice, we're going to do activity 1 on here as an in-class activity. So when we get back, activity 1. So there's a place called Paden City, West Virginia, and you're going to need to use the locator tool to find that, unless you already know where it is. And go through the steps of getting all of the data like we did so far, and then so you'll be able to do step 1. I guess I still need to show you a few things before we can actually start this. All right, so we'll do the break and then pick up from there. Like what I've been showing you? No, this was just to learn some of the tools. Activity 1 is in a different spot. But before you start on activity 1, I want to show you how to draw polygons. And so I need to turn on the street map again, because I'm not seeing the ridge lines that I wanted to have to do that. So I'm going to go get the street map once again. For that location? We were looking at them before, weren't we? I think it depends on how far zoomed in you are. Yeah. See, there they are. Yeah. If I zoom in a bit more, okay, they're still there, still there. Maybe I zoomed out too far. Oh, it's still probably processing. Yeah, so when it finishes processing, it might be gone. Yeah, all right, so I'm zoomed in too close. You get to see those beautiful ridge lines when you zoom out a bit. Processing, processing. Not there. Zoom out a bit more. Yeah, try and zoom out to the point to where you can see those ridge lines, because what we're going to do is we're going to draw it and manually delineate the watershed. So I guess to do that, to be able to see the ridge lines, you need to be zoomed out to this level, to where you see Merritt's Creek, Halls Hill, County Road 17. All right, so here we are. Now if you wanted to create a TIFF at this level to have those ridge lines, I'd right-click, export, and then set the resampling to 1. With lines. All right. So now I can turn off the street map, which is the streaming version. Oh, you got to be kidding me. All right, well, I'll just take yes for an answer. All right, so Let's switch over here to the map module. And what we're going to do is we're going to draw this watershed boundary to see if we can manually figure out what we think the contributing area would be. Because obviously there's a culvert going under that road. And we've got a watershed of some area that there's going to be water going down through here. And we want to find out how big that culvert is. We have to know what the watershed area is as a starting point. Okay, so we're going to create a feature arc with this tool, and then you can just start, every time you click, it drops another vertex of where that watershed boundary is. Did everybody zoom in to the point, zoom out to the point where you saw those ridge lines? When you are in the map module, then it'll bring up these dynamic tools. It's the third one from the bottom. It's the create feature arc. Okay, if you have to start over. All right, and then I'm going to double click at the end so that it goes on top of it. All right. So all I've done so far is just drawn lines. Did you have a problem?
No. What if I went all the way?
You can edit the location of them. Let's see, where is that? Okay, select a feature vertex. So if you zoom in and you have this tool and you click on where one was, I think you can move it. Yep. See, I'm clicking and moving that. So any place where these vertices are, you be able to move it side to side a bit if you need to. All right. So when you've got this line, if we wanted to look at the properties of it, we could select this feature arc and look at those properties, and it will tell you the length of it. So this path is about 1 kilometer in length, but it's not telling me in the enclosed area yet. We have to convert it from just an arc into an enclosed polygon to be able to get the area out of that. And so what we want to do is select the feature. Okay, wait. Select feature arc, which is the what we're doing right now. Right click, and then convert to build polygon. All right, and then now that it's built a polygon, I can select a feature polygon out of that, and then it tells me the enclosed area. And so then it says here that the area is 71,000 square meters. You select the feature arc. So once it's selected, like you're just seeing the length of it, then you right click, and it brings up this build polygon option. Yeah. So once you've built the polygon, then you can select the polygon, and then it will tell you the area of it. Now, the units right now are in meters. Let's say that we want to know how many acres that is. We can go into the display options, and they've changed some things. Yeah. Of course, yeah. All right. Well done. Sometimes it's right where you're... All right, so we want these units, we could have it do basin areas in acres. Now, what I'm not sure about... M is meters. When we were in here, you mean? Yeah. Well, once we actually delineate the watershed, then these units adjustments here, it'll give you a little report. Apparently, I guess it doesn't update it for the properties. We'd have to do a manual adjustment if we're manually delineating. All right, so the area of this watershed is 71,000 square meters, and now I'm curious, because I know when I've delineated that before, about how many acres that is. I want to convert 71,000 square meters to acres. 71,000. 17 acres. Yeah, I think that lines up. All right, so you have the handout there for Activity 1. You'll be starting from scratch in Paden City, West Virginia. Go through the same process of finding the watershed, and sometimes that's the hardest thing, is finding the crossing that you're interested in. So think of Activity 1. Someone told you that there's a crossing of the road. They're going to be putting in a culvert, and the watershed crosses at the intersection of Gamble Run and Paden Fork Road, which on the map appears as Van Camp Road. I'm going to pause the recording and I'll circulate around and address your questions. Interesting to see how close we get as we each trace the watershed boundary. You know, like what's the standard deviation in this? Ooh, that's pretty bad. One of us is not good at that. Having the computer do the delineation makes it a lot more standardized. So for this one, I got 113,000 square meters. 113. You guys get. So let's start a new project. You can save this if you like. Actually, we should save it just to get in that habit, and also because I want to show you what kind of files it actually creates when you save a project. So if you save and browse to the location where you want your files to be stored, here I've got my temporary folder. Okay, I'm going to call this Paden and save it. It'll save a .wms file, and other things as well. So what we've got so far is Paden.wms. It mistakenly thinks that's a Windows Media Player file, and so we would need to change the file associations to be able to just double-click on that and have it open up with WMS. And here you can go to that by like default programs, and I think we can set the WMS extension so that choose default apps by file type. And so here it has a really lengthy list of file types, and if I scroll down here to the bottom, it's continuing. Scroll down. Hopefully it will eventually. Because we want to be able to double click on that WMS file and open it in WMS, not in Windows Media Player. All right, so here WMS, there it is. All right, so we want to change it from not Windows Media. It's not really giving me any options, is it? Maybe I have to Oh yeah, always open with, yeah. So right click. I'm surprised it's not giving me the open. Right click, okay. Open with ... and then more apps. But this time, look for another app. I'm going to force it. Scroll to where WMS is installed. I want it to open it with the executable called WMS. I guess maybe this. Yeah, that seems right. Always open it with this. Yeah, it worked. All right. So now it's correctly associated. So additionally to this WMS file is just kind of like a meta file that tells you for the project what's the projection, what are the extents, and what are the names of the other files involved. And so the feature objects that we draw may be stored in other files. And so depending on how complicated your WMS file is, there may also be like elevation maps and shape files and a whole lot of other features that are bundled there. And so like if you're sending someone your WMS project, it's not enough to just send them only this file. You'd have to send them this file and then every other file that is being referenced inside of WMS. All right, so I'm going to open this one again, my Payden area. I guess we didn't have to go to all that file association nonsense. I could have just opened up the program and then said File, Open, and then browsed to the location, and it would have opened just fine. I guess it's just being stubborn. All right, so here is my area of interest, and so what I'm going to do is I want to get the elevation data for this location because I want to be able to have it automatically delineate the watershed. I'm going to turn off the stuff that I've drawn. Let's see. Yeah, that's a coverage. It's my drainage coverage, the thing that I drew. So go to the wizard hat on a roller skate icon, which is Hydrologic Modeling Wizard. And we've already, this is where I was saying how it kind of like has the workflow already for you, like line by line what you need to do. Does everybody have that Hydrologic Modeling Wizard open? So if you were starting from scratch and you didn't even have your project bounds defined yet, it would take you to that. You can skip through down here where it's doing next and back. This is where you can skip. Now, it already knows the UTM zone. I'm going to make sure that the project boundary is defined because I want to have it get the DEM data. So I'm just going to click OK. And then you see it's got the coordinate values of each edge of the rectangle. Click Next. And for the watershed data, you can either open files that you've downloaded from somewhere else, or here's this magical tick box here, Use Web Services. And the web services makes life so much more easy compared to when I learned WMS. I learned WMS in 2000. Now it's 2017. And the internet wasn't as smooth a place as it is nowadays. It was really a nuisance to go get this data manually 17 years ago. All right. Click Next. And then it gives you like this list of all of the different data sources it can download and automatically import into WMS. Now, later on, I'm going to ask you to get this National Land Cover database. And I'm going to ask you to get the soil type data. But for today, we're not going to do the soil type or the land cover. We're only going to get the DEM data. There's different resolutions available. The default resolution for this area is the 10-meter resolution, so we'll just use that. It'll be fine, I think. And then click Download Data from Web. And it'll take a few minutes. This elevation cell size is similar to the resampling ratio when we're downloading the pictures. You can tell it to get the full resolution, or you can have it like resample the elevation data. Since this is 10-meter data to begin with, getting the 10-meter size means it's going to get the full resolution. But if we were zoomed out and we wanted to thin out the data points so that it took less time to download and a smaller size to store, if you had a really big watershed, hundreds of square miles, then you'd maybe want to increase the cell size. But we'll just leave it on the default of 10. And so I'm going to close this wizard. I can come back to it anytime I want. But now that I close this wizard, you can see that it's automatically generated some contour lines based on where things are. So I'm going to turn my drainage back on and see if that kind of corresponds to where I drew. Now, the ridge line, maybe you're not used to looking at contour lines. The ridge line is here. So it looks like I'm a little bit to the left of the ridge line in this region. A ridge line is it's where if you drew a line, it would intersect perpendicular. Now, the bad thing is that it's not including the area that I've defined. I don't have enough of the elevation. You see how these contour lines don't include the entire area that I previously thought was my watershed area. So I'm going to have to go back again and get that data another time. So I'm going to have to redefine my project bounds. So I'm going to go back in here to define and then zoom out just a touch. So I'm going to step out, use the zoom out tool, and OK. And now that I've redefined my bounds, I think I probably also need to go and get the data another time as well. So here in the Hydrologic Modeling Wizard, go to the next step. Now what I just did, it sometimes happens, like where you won't see the tool until you close the window and then bring it back up again. And then you'll see the wizard tool again. So I defined the bounds, and now I'm going to go get the data another time. Okay, so download the data from the web. All right. So now I'm going to turn off the one that had originally downloaded, and now that I've got the wider version of it. All right. So you can see I've got the contours. They can be turned on and off. So does everybody have that? Does everybody have the contour data that encompasses the watershed? Yeah. Got it? Good. You've got it? Good, good. So, I think this thing. Okay, so let's do this one. And project bounds. Okay, good. Use web services. I don't know why this is showing up as blocked out. I'm not sure. Oh, well, let's just do download data from web. See, it has the checkbox there. Oh, okay, we need to save the file here, so. Okay, save it in a certain location, like on the C drive, someplace you want to save the file. Okay, give it a name, you know, like tutorial or whatever you want to call it. Okay, now, yeah, save, click save. Yeah, yeah, so it was grayed out because you didn't have a file name set yet, so click OK. All right, good, I think it'll be ready. All right, so the data that it just downloaded wasn't these colored lines. Does everybody know what it actually just downloaded? Do you know what a DEM is? Who here knows what a DEM is? Digital Elevation Model. Remember we were talking earlier about pixels? What it just downloaded was a series of dots. And each of these dots, it knows three things. It knows the X, the Y, and the Z. And so it just downloaded a grid where it knows the elevation of all of these dots. And so what we're looking at the result of those dots. We're not looking at the data itself. And so what the program is doing is kind of on the fly generating these contour lines based on the surface that's defined by those dots that are in the background. And the 10-meter thing that it was saying earlier was the spacing. It's 10 meters between each of the dots. All right, so here's what we're going to do. Go back to the wizard roller skate, hydrologic modeling wizard, and so we can jump around in the workflow, or you can just next through it. We've defined the watershed bounds, we've got the data. Okay, next thing to do is to run Topaz. What Topaz does is it takes these dots and it does an analysis. It will pick a dot and then it will say, what are the elevations of all of the adjacent cells? And then it looks and sees for all of the adjacent cells, if water falls onto this pixel, what direction is the water going to go? And it will go in the direction of the lowest elevation. And so, you know, for this cell that I've got circled here, for this dot, if this is the lowest one, then the water's going to go this way. And so Topaz, what it does is for all of the dots in the data set, it compares them one by one and it draws these direction arrows. And it kind of comes up with an idea of all of the flow paths for the entire data set. And so when I click Compute Topaz, for our watershed, we're not zoomed in. We're zoomed in pretty close. And so it's not a very big DEM at this point. There's not a lot of points. And so if I compute, then it'll do it almost instantaneously. See how it says normal program termination here? If you have a big watershed, like I was doing a watershed out by the Greenbrier one time, and it took several hours for it to compute Topaz. If it's taken that long, it probably means the watershed's too big, like you're going to crash your program over and over again. But so now I've executed Topaz, and if I close this, sure why I'm going to go here into the display options, because in the drainage data here, this is funny. See where it says minimum accumulation for display? Topaz knows where the streams are going to be, but it won't show you until you tell the program how much upstream area there has to be before you assume there is a stream forming. So right now it's in square miles. Our watershed's much too small to be talking in terms of square miles. I'm going to change that to area of acres. Okay. So let's say that we want to have 5 acres upstream before it starts to show a stream. And depending on how hard it's raining, maybe in the real world, maybe you'd only need to have 1 acre of upstream area before you actually start seeing a physical manifestation of a stream. But let's just say 5 for now and click OK. And so now it's showing these blue lines where it expects the stream is going to go. What's interesting to compare is, you know, the map that's in the background and where it thinks the streams are going to be in comparison to where they actually are. And they line up pretty well. Any differences that you see are usually because the elevation model is maybe a couple of years ago and people have gone and put a road somewhere and actually changed the surface. All right, so this is where it's starting to get exciting. If we go back now, any questions so far? By the way, I'm not sure why I'm seeing my image because it's not here in the Project Explorer. So I'm a little perplexed to why I'm seeing the image. But I guess I'm not going to let it bother me. All right, so go back to the Hydrologic modeling wizard, and where we were at in the workflows, we just calculated Topaz and then made changes to the upstream area. I guess I could have done that right here, the accumulation threshold to display. If we change it to 1 acre, then we're going to see a lot more blue than we see right now. So see how now the streams are branching out so that it's saying there has to be less upstream area before the streams form. But if I go to 8 acres, then this is maybe where the streams would be on a dry day. Or on a very dry day, the streams would get even shorter. All right. But what I want to do now in the workflow is choose an outlet location. And this is where you're going to tell WMS where the culvert is going to be, because it is, right now, WMS doesn't know really what we're interested in, like where should it start preparing a model for. This is where my culvert is going under the road. And so I'm going to put an outlet right there. And ordinarily you wouldn't have drawn this feature object in advance. And so I'm going to actually select that feature polygon and delete it. I'm going to select the feature arc and delete it, just so that there's no confusion about what we drew earlier has nothing to do about what's about to happen. You know, what we're going to do at this point is we're going to say that there's an outlet of the watershed right where the stream intersects with the road. Okay, so I'm going to go back into the workflow, Hydrologic Modeling Wizard. Oh, here's the wizard. All right, create outlet point. And then where you click on the map is going to drop that outlet point. So I'm going to have it be this spot right before the road, this last flow pixel before the road. So now I've put that outlet point there. And then the next thing in the list of the workflow is to delineate the watershed. And so if you click this Delineate Watershed button, it's going to say, it's going to start here at the outlet, and it's going to go the opposite direction that I was just telling you about, all these dots. It's going to start downhill, and it's going to start working uphill to all of the connected pixels that would feed water to that location. And it's going to do it very quickly. So I'll click Delineate Watershed, and I can close this. And so now it has identified where that boundary is. And so it thinks that it's 28.85 acres. And so if we go back over here, convert 25, what was it? 28.85 acres to square meters. Oh, I erased it. Why did I do that? You know what you did earlier. Who was closest? 116. Some of you guys got 116, right? Or was it me? I was, huh? Yeah. Wow. Well done. I think I was 113, now that I come to think of it. All right. So the nice thing about what just happened is it's not subjective at all. You know, it's a computer program that delineated that watershed for you, and so it's, as they say, justifiable. You know, like it's defensible. Now, the watershed boundaries look a little bit jagged here. Any idea why it's so jagged? Why isn't it just a smooth line? Yeah, it's 10-meter data. This is a relatively small watershed. We could drop another outlet somewhere, and this is, I think, good practice. Let's put in another outlet. Here in the drainage module, we don't have to go into the wizard every time. You know, here is the button to create an outlet point. So I'm going to create an outlet point on this left branch of it, just anywhere on the, well, not anywhere on the map, anywhere on the stream. But if I have it delineate the watershed, DEM, delineate basins, it gives you this warning that it's going to redo it based on where the outlets are. Click OK. All right. So do you think my watershed really looks like that? Why is it giving me this vertical line here? What's the interpretation of that? Yeah, it means that, remember when I defined the project bounds, this is the end of it. And so sometimes identifying your project bounds is an iterative process because you know where your outlet is, and you'll say, here's my outlet, but then you'll delineate, and you didn't zoom out far enough when you did it the first time. And so it's kind of a balancing act of getting the right spot for your area. All right, so now go on to Activity 2. In Activity 2, I ask you to do this same sort of stuff, but for the Huntington area. And the nice thing is that when you have a watershed defined, if I go back here into select the drainage unit, I can click on it, and it gives me more than just the area. It calculates the area, but it also tells me things like BS. It's always good to know how much BS there is. And BS stands for basin slope, by the way. If you click on it, then it will give you a little definition here. Basin overland slope. And the maximum watercourse length. So these are some of the parameters that go into calculating time of concentration. Calculating the watershed area is going to be on just about every hydrologic model. And so go through that activity. Activity 2, I'm asking you to do it in Huntington, West Virginia, near Darnell Road. I even give you a couple of pictures to help you identify the outlets. One last thing I guess I haven't showed you yet is how to trim a DEM. So let me do that before you move on. If you see how I've got two different DEMs here, this first one was one that was too small. I can get rid of that. I'm going to delete it. But then this other one, if I right-click, one of the options here is to trim the DEM. So you don't want to have more data than you need, so you can trim with a polygon interactively. I'm just going to click around the watershed that I'm interested in, and then it got rid of all the rest of the elevation data. And I'm also going to delete this old outlet. Deleting watersheds is sometimes a bit tricky. I deleted it. Anyways, all right, go through activity. So basically, if you want to trim a polygon, you just right-click on it. And then the advantage there is that it saves space. And you can export your DEM by right-clicking on it and save as. And it will give you these options here. And there's DEM files where you could save the elevation data separately. All right. One weird thing about this is that when you are creating a file name, it doesn't actually save until you click the Save button. I don't know why. Like, usually you'd think that this would save it, but I think it doesn't until you click the Save button. A lot of times in West Virginia, you can take these roads to be kind of a surrogate for where the creek is. You know, so often the road is going alongside the creek. Area 1155.7 acres. Maximum flow distance. 11,807 feet. Also have the maximum flow distance. All right, so to trim the DEM file so that you don't have the whole thing, we only need the DEM that's under the watershed. And so you right-click, trim, polygon, and then interactively you can just go around the outside edges of it. Once you double-click, then it'll throw out all the rest. Now, be sure that you save your file. It's always interesting to look and see what new files have been saved in that project folder. Because now we've got Darnell. We've got several different Darnells. We've got the elevation file here, the watershed tree, project file. And if you want to have these labels up, you see how I have the area, basin slope, flow distance, and so on. You can click on the display properties button, the display options, or you can go to display options, and then under the drainage data tab, you can put click boxes here and it'll tell you any factor that you want, so you don't have to get it from the properties. Just turn it on. You can export the elevation data. Right-click, Save As, and then we'll change the file type to be a DEM file. And so then I'd call this Darnell DEM. And the advantage of having that is that you can start a project over again and have the elevation data already available to you, and you don't have to go get it from the website. So it's similar to how you exported those geotiffs instead of streaming the data all the time. All right, so let me give you the, I never gave you guys the notes. You got to remind me. Not that I don't know. Here, you can have them if you want them. A little late at this point. It's your fault. You didn't remind me. Look at how mad you made me. That's what I tell my kids as I hit them. Just kidding. All right, so here's the homework assignment. The homework assignment is just exactly what we did. Repetition is the way to learn software. Oh, you want to give this to your buddy when he gets back from Virginia Tech? He's not spending the night down there, is he? I saw that he lost his mullet. Leukemia, I take it.
I don't know if it was used up all day or
Yeah. All right, let's take one last glance at the announcements. Okay, so this homework assignment is due next time. That's the only announcement. All right. We'll continue talking about WMS. We'll actually start preparing curve numbers next time. We'll see how, it's super nice to delineate the watershed boundary. It did it automatically. What's even more brilliant is when it calculates the curve number automatically. That's when you really start appreciating how it saves time. All right, have a good one. I'll see you next Wednesday.